All right. Just before I take you guys' questions, I already sent the exam for printing, so there's some information I can reveal to everybody, just in case it helps. So there are 32 multiple choice questions. And single answer for each. That's a good news, right? Kind of unlike your written test. That's something I can tell you, so you don't need to panic. Single choices only. And 2 marks each. So that means you got 64 marks over there. The remaining 36 marks, there are 4 written test questions. 4 written questions. I don't quite remember about the distribution, but it's more or less equally distributed for the 4 written questions. But in total, there will be 36 marks. That's your exam. Okay. I believe the exam will keep you quite busy. So make sure you're in your best condition to write the exam. You know, it's just the nature of the cumulative exam, right? That's what I can tell you for now. All right. So why don't you guys ask me questions? We'll see how that will lead us, right? Farad, go ahead first. Yeah, I don't mind telling you, since you ask. One of them is about to implement a recursive method. And of course, between now and possibly Monday evening, your best bet, preparation. Understand about the lectured example, about how we do recursion on arrays and recursion on strings. Okay, lectured example. And also, make sure you complete lab number 5. And if you really got time spare for the exam, look at the coding bed. The method itself for you to implement the exam is not a very advanced example. That's not really what I would expect, given that you guys only got about 2 weeks to learn about recursion. So that one there is a reasonable one at this level. So I would say as long as you feel comfortable about these 2, if you're able to do some extra exercise on your own on coding bed, you're set for that question there. Okay? Yeah. Okay. Right. So where, let's say for the written question, where let's say if you're supposed to write Java code, I think of course if you miss like a semicolon, if you semicolon is definitely okay. You know, we definitely will be quite lenient on that. However, for example, I'm not saying it will be on the exam. It may be or maybe not. Right. Let's say for example, if the question is about doing typecast, right? This might be a very quick review about what we did earlier. For example, let's say if you got, I'll just make it symbolic. If you got, for example, let's say you want to cast an object into C and then call the method M, versus if you got obj and then do the cast.m. We spoke about in the lecture about these 2 are not really the same, right? Very briefly. Oh, Farad, why don't you start? How are they different? These 2. Of course. What about the first one? Yeah. The return value will be cast to C. Absolutely. How about the second one? Exactly. Yeah. So let's say if this was the written question, in that case, of course, if you miss the parenthesis, it's not like as light as missing a semicolon. So we might take a little bit more penalty, but we'll be reasonable. After all, it's only a written test. It's not really like a programming test. So if you miss some very minor, some syntax error, that's okay. We can be tolerant. But for the critical part, we will be a little bit more strict, like in this. Yeah. Okay. That's okay. As many as you like. Okay. So let me try to recall. I don't mind telling you. I may not tell you the subjects, right? Okay. I can tell you that for all the, of course, one of them I already told you is going to be implementing a recursive method. The other 3, are more like at least one of them is about to justify certain things. Okay, for example, if I give you a fragment of code, maybe involving exception, maybe involving assertion, and etc., I might just ask you what's going to happen at the runtime for that method, for the fragment of code, and justify your answer. So in that way, you have to write some English words, English sentences to justify. You will be given some answer box to answer them. There will be one or two questions there. You may just have to write certain line of code to fill it in into some existing code given to you. Of course, you need to understand what's given to you before you can insert some line of code. I believe one or two questions in the written are like that. That's more or less what you're given. Yeah. Okay. Anything else about the? But I think many of the subjects that we are going to cover in the exam, many of them actually overlap with what you were what was covered in your 3 written tests. So make sure you go over them. Make sure you learn all the concepts in the written test. I'm pretty sure that will also prepare you well. There will be some subjects which we didn't get a chance to cover in the written test. There are some. Okay, not that many. There are some. So you definitely want to make sure anything that we didn't get a chance to cover, make sure you also review them for the lecture. You know, for example, right? We definitely tested you on like a dynamic binding, you know, for the written test. We didn't really test you on polymorphic array, right? That's a very important subject as well. So you may just want to make sure 3 things over here. Number 1, so these are something we didn't cover, but very important topic. So that's a polymorphic array. If you're not too sure about what that really means, you can check back to your notes or recording. That's one thing. And also polymorphic method parameters. And also polymorphic return types. So these were kind of the final topics we actually covered in the inheritance lecture. So make sure you also understand them. Right. Yeah, things like aliasing, for example. So the example that we did in the class, and also the question we gave to you in the written test, definitely that'll be helpful too, aliasing. Okay. Okay, I can, yeah, as I promised to Marcus the other day, I'll try to give you guys maybe some written exam questions. But let me make a little warning. Though those questions were mainly from other instructor, it may not be exactly what you will see on Monday. Only if you actually want to get some extra practice. Maybe useful, maybe not, but I would definitely say only do those questions when you actually have already gone through all the materials and feel very confident. Okay? Yeah, what you shouldn't do is to really only take those questions to guide your study. Don't, because as I said, those were designed by other instructor, right? Yeah, well, I can tell you what I usually do when I make an exam question or test question. I go over every slide that we went over in the class. I went over every page of the iPad example, and I thought to myself, okay, is it really worth making a question out of this since I covered this much in depth, right? That's what I typically do. So definitely to take my exam, my style will be as long as you study the lectures and also what we discuss in the class, you'll be fine. But don't panic on Monday because you will be a bit overwhelmed. That's very typical for the cumulative exam. Just answer question by question, and when you go to the written question, they're all multiple choice. If there's any question you're not too sure about, skip them. Of course, you end up skipping every question. That's another story, right? But just skip the question you're not too sure, go back later. Oh, one more thing. That's also important. Okay. We are not going to use any Scantron for the multiple choice. In some way, that might be easier. So let's say if you got some multiple choice question there, and then you got option 1, 2, 3, 4, you're going to use a pen to circle your answer. Okay, this is something I will clarify tomorrow by E-class announcement. I just want to tell you, for your written question there, you can write either in a pencil or in a pen. That's okay. But when you circle the answer for your multiple choice, you must circle in pen. Not red, actually. Okay, in pen, not pencil. Okay, that's something I will definitely clarify, maybe tomorrow by sending some E-class announcement. Yeah. So you don't need to bring like a specialized pencil for the Scantron. Just make everybody easier. All right. Any other question? But all the lecture recordings are there. Everything is there. So I think since I didn't really make it to the office hour on Thursday, I promise I'll make it up. So I will try to hold another 1 hour office hour so you guys can talk to me on campus. Maybe I can make it maybe sometime on Monday. So right before the exam, if you want to ask me some last minute question, yeah, I'll announce. Yeah, since I said I'm gonna make it up 1 hour. Yeah, I'll be in touch. Do you need to know how to trace the stack? Yeah. Okay. Yeah, I think there are two things over here. I think they're important to know. Tracing using stack. Okay, I think there are two things that are important. So number one is the caller callee, which we actually test you about in written test 1, I believe, right? And the second one is about how to use a stack to trace a recursive call. For example, in the lecture recording, the Fibonacci, right? That's something I think you should know them. Yeah. Okay. They're important because they will also help you once you get to 2011. Because stack is one of the data structure that's so useful. So that's something it might be good also for you to get prepared for 2011 next term. Yeah. All right. Yes. Written test number 3. Which question? Okay. Sure. That's not a problem. Let me just, first of all, bring up the E-class, and then you can tell me which question it is. Okay. Let me go to written test number 3, which is over here. And then, okay, preview. Okay, is this one you're talking about? This one, huh? Okay, good. Sure, not a problem. Okay, there are two things over here. Let me try to see if this might work. First of all, I would need this. Let me see if I can set it up on my iPad. Oh, looks like it's gonna work. Very good. Okay, bear with me. That's the first part. And then the question. Okay. There we go. Okay, so these are, I'll enlarge, I will zoom in later when we need it. This is definitely something you will need for the exam. So given the class declaration, you should be able to draw the diagram accordingly. Okay, let's now do this one here together. Okay. Okay, good. So A extends G. I'll fill in the methods in a moment. And B just by itself. C extends G. And also D extends A. E extends B. F extends A. And also G extends B. Oh, there we go. All right. Good. And then let's now annotate the methods quickly. So for example, in class A, we got method M. Okay. In class B, we got method Bm. In class C, we got method also Bn. And also in class D, nothing. And in class E, nothing. In class F, we got Bm. And in class G, we got Bn. Okay? So now, before we even attempt the question, you should really tell yourself, right, what's really here. Number one, you can see the method Bm was first defined at this level. It was overridden in this one here. Also, it was overridden again here and here. Okay, just for example, just to test you. If the dynamic type happens to be E, which version of Bm is going to be invoked? Ferrets, go ahead. This one is obvious. Very good. Okay. What about, let's say, if the dynamic type happens to be A? In that case, which version? Go ahead. Absolutely, the closest ancestor. That's exactly right. Here, not here, and not here. Okay, that's something you should also know too. All right, that's a diagram. And then we have 3 lines over here. Let me enlarge them, zoom in. Let's look at these 3 lines. Okay, and we say that the static type is G. The dynamic type is C. In order for this variable assignment to be valid, this must be able to fulfill the expectation of G, right? Is it the case? Let's see whether C, okay, whether C is a descendant class of G. Indeed, right? Good. All right, awesome. And this one here, similar, A is a descendant class of A. That's fine too. Let's now try to visualize this, right? So OBJ has the static type G, pointing to an object's dynamic type C. And also we got OBJ2 of static type A, pointing to an object of dynamic type A. Okay, that's what we got in the first 2 lines. And this line here is saying that OBJ should be reassigned to OBJ2. Now, question for you guys. In order for this variable assignment here to compile, what will be the requirement? You want to be as complete as possible. That will help on your exam. Anyone want to try? I'll let you try first. Go ahead. Say that again, please. Okay, that's good. I like that. But you want to, when I say complete, you want to say the static type of OBJ2, which is A, must be a descendant class of the static type of OBJ, which is G. That'll be the complete one. Okay, good. In that case, A is a descendant class of G. Let's verify. Indeed. Okay, good. And so we can do it. So OBJ, rather than pointing to here, is now going to point to here. You will need to do lots of like a reassignment like this in the exam. So make sure you know how to draw the diagram. All right. Okay. That's basically how you should really set up the question. Let's now go over one by one. First one. And as Ferris correctly pointed out earlier, here we are saying that we're going to call this method here first before we cast. Agree? Since we don't have that extra pair of parentheses. Okay? So here, we want to know, well, of course, there are many possibilities here. So now, let me just say for this one. You can think about in 2 steps. Number 1, we want to simply call obj.bn. And step number 2, you want to cast the return value to f. So that will be the order of sequence, right? Okay, let's say number 1. Can we actually do obj.bn? How do we tell? Exactly. So now here, obj has the static type G, never change. Does G define Bn? Does G define dbn? Indeed. There's at least one version over there. So this one here is okay. Okay. So this one here is awesome. Okay, because OBJ has the static type of G. And can we actually cast ob.bn into F? Can we actually do that? What's the return type? Guys, this one is tricky. I'll let you think a little bit. We are basically, okay, first of all, if you look at this, just by looking at this, Java compiler would think you're trying to cast whatever that's returned from here to here. Okay? First of all, we know that we can definitely call obj.bn. But can we cast the result of obj.bn into F? That's the critical question. That's the second part. Can we or can we not? I will show you the entire question again. Look at that carefully and let me know. Any thought? If you look at my second point over here, in some ways it hints. I said cast the return value of this method call here to F. There's no return value, exactly. If you look at the bn, in G, here is void. No return value. So this is to say, you are expecting some static type over here from the return value so that you can do either upward casting or downward casting to be compilable. But the problem is, there is simply no return type. It's void. So it wouldn't compile. Okay, that's why. All right. So the second one here, cast the return value over here. This will be error, because the bn has return type void. Okay. Okay, so I'm pretty sure if you look at the answer, it's going to be, it doesn't compile. All right. All right, how about we do the second one? The second one here looks very similar, right? But they're different. Okay, look at the second one here. Apparently, we have to do this one first. Okay, now this is a cast. Is this cast valid? Okay, anybody explain if this is valid? Oh, I'll show you the whole thing. Yeah. Can we cast obj to F? Farad, go ahead. How do you know that's downward casting? It's G? Mm-hmm. Exactly, exactly. Yeah, so Farad, let me ask you a follow-up question. It's not here, okay? If the static type is here, how many classes there in the hierarchy are going to give you a compilation error if you're trying to cast into it? Which one? Exactly, very good. You really know the subject, very good. Okay, so what I'm trying to review over here is about, remember we talk about different categories of typecast, right? If this is static type over here, if you just want to know about compilable versus non-compilable, either upward to all the ancestor or downward to all the descendants, neither upward or downward will be the only one is here. Okay, so you should really know. And of course, if you want to know about class cast exception, you have to bring dynamic type into play. Okay, but that's another issue. Okay, good. So this one here is going to compile. Okay, so now we have to answer this. Okay, so for this one here, I'm just going to put it here. Okay, the first step is to do cast obj. Okay, that's what we do first. Compiles, because it's downward cast. And the second part is about calling the method. Can we really call this method here on the cast expression? Okay, let's now look at this. This one here. Is this valid? We know that this part here is valid. But can we say this part here dot bn? That's a question. Go ahead, yeah. Okay. Okay, let's give it a try to see what happened. All right. Very good, Paris. Let's see. So now at the runtime, right? If we try, so let's talk about compilation first. Okay. Let me just go a little bit more detail. Okay. First of all, compilation. Let me answer compilation, and then we'll talk about runtime. Okay. Compilation-wise, we downward cast into F. So this is the type of the cast expression, F. And can we invoke Bn on some expression of static type F? Yes, indeed, there is some method here. So compilation-wise, check mark. Okay. What about runtime? In which case, we have to bring the dynamic type into play. So let's now try to find out. Dynamic type for obj is, as Farah said, is actually A, right? So this is the dynamic type of obj. And if you're trying to cast obj into F, it will be class cast exception free if the dynamic type A can fulfill the cast type F. As you said, it's not the case. It will only be the case if A is a descendant of F, but it's not the case. All right, so very good. Class cast exception. So it compiles, but you write into exception. Okay, very nice. You want me to go over more, or you kind of get an idea, right? Oh, but yeah, okay now, right, for the first one. Yes, so here this will not even compile because this part here compiles. However, when you try to do this cast, it's not going to compile because there's no return value from there. That's why. Let's say, well, it depends on what the return type is, hypothetically. Let's say the BM over here, rather than just void, it might return certain class C, let's say. Okay? In that case, this cast, let me say it again. Hypothetically, let's say there's a return type C. This cast over here will only compile if the return type will be either doing an upward or downward casting with respect to F. And it will be class cast exception if the dynamic type of obj cannot fulfill F, right? The same principle. Yeah. Yes, you got to look at it. Yeah, exactly. Yeah, whatever type you declare as the return type here, that will be the static type whenever you make the method call. Yes. Awesome. Yeah, if Ferris, go ahead. Oh, sorry, which one are you talking about? Over here? Oh, there's a constructor, yes. Oh, the constructor actually never has a return type. Oh, yeah. You just return, for example, here, you replace the void, maybe by some class C. That's what you would do. Oh, just like a normal method, right? Just don't forget. So basically, the syntax for Java is you always should really put some return type. If there's no return type, you put void. You don't just leave it empty. And then if you do have a return type, like a get point, maybe get vaccine, etc., right? Just put a class name. Of course, sometimes it could be an array of C. That's also possible, right? Yeah, so like a get, I don't remember. We have done quite many in the labs in the programming test, right? You can return an array of objects as well. Right? All right, very good. Yeah, I would say this kind of question, you definitely would need to face that in both the written test and the multiple choice question, both, okay? No, actually, I like this review. I don't mind if you guys somehow just touch what I'm going to test you on. in which case I'll definitely still go over in detail. I think that's good. That's to your benefits. All right, next question. Go ahead. Polymorphic argument? Sure. We can either go over the example in the lectures again, or I can create something on the fly. Mm-hmm. Confused? Okay, why don't I create some very simple example? Okay, why don't we do that? Okay. Let me make it symbolic. Okay. Yeah, let's say this. Let's say we got class A here. Let me make it a little bit simple. Okay. And let's say here, let me think. Okay, ABC. And let's say we got another class. Let's call it collection. Okay. And then in the collection here, we got an array. Let's say an array of A items. Okay, that's an attributes. Let's not worry about private or public. And then we have maybe some mutator. Let's say void. Let's say add some new item, A. And then some item over here. And you know pretty well how to implement this part. You just need a counter and then implement. Let's forget about that part. Okay, that one I'm pretty sure you can do. It's a very typical, you can think about this collection here is like the student management system. And then here, items like a students. A is like a student, a resident, and non-resident student, right? Similar. Okay. Let's try to do some exercise on the polymorphic arguments as you requested, and also call by value for sure. Okay. Let's see. Okay. So let's say this. Let's say we got just one more class for application. Okay. Or test, doesn't matter. Just another context. Okay. And let's say we declare some object, let's say collection, let's say C, a new collection. One thing I didn't really write out, but I should definitely know, in the constructor of the collection over here, of course, you have to make sure you properly initialize the array, the counter, right? I'll just write it down here. Just make sure you got to do the proper implementation here. And let's try this. And of course, you're going to say C dot add. And then you're going to put some argument over here. Okay? Something here. Okay? For now, let me just say argument, ARG. Of course, I'm going to insert some lines of code over here for you to practice. But before we do this part over here, you should know that this is arguments, and this part here is a parameter, right? So this part over here in pink is the arguments. And this part over here in green is a relevant parameter. Okay, let me just write it down. This part here is the parameter. And this part over here is the arguments. Call by value says that when you try to call this particular method here, there would be some implicit variable assignments, right? Varets. I remember you got it wrong the first time. Sorry, I'm going to keep calling you. Go ahead. Yes, okay, very good. In this case, item equals argument, right? Okay, good. You see, I got good memory. So it's going to be parameter item equals arguments. Okay, are you okay so far? Okay, so now you can see this is a variable assignments. That means it will be subject to the rules that we have been talking about. That means the static type of the arguments should be a descendants of the static type of the parameter, which is item. That's how we derive the rule. So that means any argument you put over here, you must make sure its static type must be a descending class of A. In this case, it's not too difficult because A happens to be the top of the hierarchy, right? That's what we typically do. When you actually want to have polymorphic parameter, that's something maybe we'll speak more about in 2011 and later on your software design course, but just for some look ahead. Normally, if you actually got some inheritance hierarchy, your design for the method parameter should really use the highest class possible, because in that way, arguments, you allow more possibility. Because any arguments whose static type will be a descending class of the parameter, you can just pass. Otherwise, if you choose the bottom of the hierarchy, in that way, you only got what itself as the descending class. In that case, you don't have many choices, right? It's more like a design concern, which is not really covered in this course. Good. Are you okay so far? Okay, let's do some exercise together. Okay, I'll just give you some example here. I'll give you 2. Oh, let's see how many I can come up with. The first one here, let's say this one's easy. Let's say this. Let's say B, and then OBJ. And then can we say C dot at OBJ? That's a simple one. This one is obviously okay, right? Because the static type of OBJ is B, which is a descending class of A. Okay? Let me give you something that's not okay. Okay? I'm just going to do it directly. Okay? C dot at Okay, can you see what I'm doing here? Okay, so here, this one here, we are basically saying OBJ is somehow upward cast to the top. This upcast is always possible. And remember there was one exercise we did in the inheritance lecture. You can cast from some arbitrary class to another irrelevant class always. How do you do that? Upward cast to the objects and downward cast to that class. You can always do that to make it compile. Of course, whether or not you write into class cast exception is another story. Okay, but this one here, does it compile or not? Are you sure? Think about this one here. There might be something similar in the exam. I don't quite recall, but this one's interesting. The way for you to judge, right? I really don't want you guys to guess. So think logically. So, okay, before I take your input, we know that this part over here is the argument, right? The whole thing. What's the static type for this argument? Is it the static type of OBJ, which is B, or something else? Object, because once you do the upward cast, the expression has a different static type already, okay? So that means after this one over here, the cast expression has the static type objects. Okay, so that means you have, if you go back to this assignment over here, the arguments has the static type objects. Is it a descending class of the static type of item, which is A? No. No way, right? So that's why this one here is not going to compile. Yeah, 2 examples for you. Okay, good. All right, anything else? Of course. Okay, maybe written question one, a question 1 for you, but may not be exactly question 1. But let's written test 2, right? Okay, let's take a look. Let's take a look. Let me go there. Written test number 2. Oops, no, I don't want to go there. I don't want to reveal anybody's score. It's good I didn't click on that. Okay, that's not good. I'll get lots of complaints once people see the recording. Preview, there we go. Tell me what to stop, right? Tell me which question it is. Is it this one? Okay. No, I'll make it larger for you. If not, is it this one? No, okay. No, okay. I'm glad it's not this one. This one will take some time. Okay. This one? Okay, that's okay. Just tell me to stop when we get there. Because it randomized, so I don't know which one it is. This one? Okay, good. Okay. Awesome. What I would do is, let me capture that. And then I'm going to switch. Oops. Okay. There we go. Good. Yeah, I believe that one is about short circuit, which is also an important topic for sure. Okay, so we got an array, NS, okay, of length number 3. But if you want to visualize right away, you may do that. So NS is pointing to an array of length 3. So that means 0, 1, and 2. Okay. And then and some integer variable I. Okay. So we want to consider this block of code. Okay. You can see we are using OR over here, or over here. Right? Can you briefly describe what short circuit effect really means for the OR operator? If you recall. Not really? Okay. We definitely have to evaluate from left to right. I agree. When do we, under what circumstances for this evaluation here, do we not bother to go ahead, evaluate the next one? It's already, absolutely. Because we know logically, if you got any argument, any operand is already true for this junction, the whole thing will be true. So feel free to maybe check out the lecture where I talk about it. I think I talked about it back in the maybe equality lecture. Maybe check it out, okay? But for now, let's talk about this one here. So the idea would be we're going to evaluate, okay, 2 points. Number one, we're going to evaluate from left to right, okay? This one here, followed by this, okay? And then stop proceeding as soon as an operand, as Noran say, evaluates to true. Of course, in the case of the %, it will be false, right? It's kind of symmetric. All right. So in this case, we're saying this. When we evaluate this, if this is true, we're going to stop evaluating. If this is false, in that case, we'll go ahead to evaluate the next one. Okay? So what does that mean? Think about this is really meant to be a guarding condition. Okay? So let's think about this. Okay? For this one here, proceed to the next operand. If it is false, that means 0 less than or equal to I. Right? You can see that I'm just taking the negation of this. So if I is larger than or equal to 0, and then we'll go ahead to the next one. If I is strictly less than 0, we don't need to go further. Okay? So that's this one. So this one is actually awesome. Okay? But the problem is, there is another guarding condition. This guarding condition here is to make sure I is not too small. It should be larger than or equal to 0. There should be another one to make sure I is not too large, which is exactly over here. Right? If you look at this one here, this one over here, happen to be the last one. Okay, so if you place that maybe earlier, that means you will say proceed to the next. If I, you can see larger than or equal to, that should be less than ns.length, right? The opposite, I mean the negation. But now the problem is, this one was placed before you index into the array. Okay. Overall, we know that this particular combination here can only guard I value that's actually too small, but not the I value that's too large. Okay, I'll write it down, and then we'll look at the answer to discuss. Okay, so that means value of I that are too large. Cannot be prevented because you will actually evaluate this first. Okay, so now let's take a look at the question. When executing the above program, which of the following value or values will result in array index out of bound exception? We want to choose those values that's too large, basically. Okay, so because the length is actually 3, so any value that's larger than 2. All right. So we can choose 4 here, 3 here, and that's it. Okay. So now if you look at this one here, for example, -1. Why -1 is not going to result in an array index out of bound exception? Barrett, go ahead. Exactly. Yeah. Exactly. Because -1 less than 0 is actually true. So that means because of short circuit, you're not going to evaluate the rest because you already got true. Right? Okay? Good. On the other hand, if you got 4 over here, why would that be an array index out of bound exception? 4 less than 0 is false. That means we got to continue. But the problem is if you try ns at index 4, there's no index 4. So you got array index out of bound exception. Okay? Just remember the principle. Left to right, and then for the disjunction or here, you will only proceed if the result is actually false. But the problem is you put a guarding condition too late. All the guarding conditions should really come before the actual array indexing. So you should really switch this one here to here. That's what you should have done. Okay, are you saying you're going to try I is equal to 3? Okay, sure, let's try that. When I is equal to 3, first of all, 3 less than 0 is false. So that means we'll still go to this one here. Right? You see, because it's from left to right, so you always evaluate this before you can check this. And when you actually get to this point, you only know that it's because this part here is false, meaning that you only know that I larger than or equal to 0. But how large it is it too large? You have no guarantee. That's a problem. I hope that can make sense. Yeah, okay. Yeah, think about it a bit more. It's a tricky question. It's a tricky one. But it's really something we would introduce to you in the first year. But many, I would say even for the student graduating, they're still a little bit confused about how this works. It takes some time. It's very logical. Yeah. You got a question, right? Oh, you're fine. Okay, good. Barrett. Sure. Written has 3. Okay. So can we leave this question here? Okay, good. Good. Absolutely. Okay, let me just go back to written test 3. And then I want to preview. There we go. So various which question? Okay, sure. I see what you mean. This one here, right? Okay, okay. Oh, by the way, this one here, Marcus is not here today. Thanks to Marcus, we actually covered that. I'll show you where to find it. I think it was in the beginning of some lecture. Let me find it very quickly. Yeah, something like that. Yeah, I think when we talk about aggregation composition kind of lecture, let me find it out very, very quickly. It's definitely before we talk about inheritance. Because that will also be very worth reviewing. It's also a very important topic. Is it? Okay, give me a moment. There we go. That's the one. All right, I think that was back in the lecture of November 2nd. Right, so if you want to check out this particular recording in the beginning, do it again. All right, but let's look at the written test. Let's go back. Oh, okay. Let me just copy that. Give me a moment. I'll set it up. Okay. Oh, yeah, I gotta switch back. There we go. Okay. Okay, hopefully that's visible. Okay, good. All right, so here, basically you got class A, B, and C. And then you got some attributes, string, attribute, string, attribute, string. And also attribute, some class type, attribute, some array type, attribute, some array type as well, right? And I think we make the assumption that over here, the corresponding public accessor for each attributes. For example, here you got something called get attribute 1, which will return a string. Here you got some get attribute 2, right, and etc. Let's say we assume that. Okay, let's look at one by one. Choose everything that's valid. Okay. The first one. Basically, when you do this, you're navigating between classes. Okay, let's do one by one. We start with, the starting context is really important. So we are starting from class C. Sorry, class B, beg your pardon. That's the starting point. All right, let's see if we can do the navigation. Can we, first of all, do this one here? ATT4I. Fine, right? Okay. And this one here is going to give us some A, right? By getting to index I. And then when we get, so now we got to navigate to class A. When we say get attribute 2, it's going to give us C. Okay, so far? Okay, and then C here is going to traverse to here. Can we now say get attribute 6? Yes, we can. Index J, some value, is going to give us B. All right, and then B here, we're going to go to B here. Okay, now the question is, can we actually access this attribute 4 that's private? It will be okay because starting context over here is B, right? That's fine. And then we're going to go for some index over here that's going to be A. So we are back to A over here. And then get attribute 2, that's going to give you C. And you're back here. And then get attribute 5, that's going to give you a string. Basically, just keep navigating. That's what you got to do. If we didn't have, for this one here, class B. Oh, that's because if you look at, let me be more precise here. If you look at get attribute 6 over here, only this is going to give you B array. But you cannot really traverse to class B just by an array of B because you don't know which element to really go to, right? You need some particular index, J. So after this, you're just going to get a B. You can see the difference here, right? Yes, exactly. Yeah, Ferret, I would encourage you to give a very quick try, maybe on Eclipse. If you simply get rid of the index J over here, you're going to get a compilation error. And the error is going to be something about you don't really have the attributes ATT4 that's defined in the array of B because you don't have the indexing notation. That's what you will see. Yeah? Okay. So Ferris, do you want to go over another one, or are you kind of okay with this? Okay, no problem. So I would suggest maybe go over this one here by using the principle that we discussed in the class, November 2nd lecture. Okay, I think that will help too. Sure, no problem.
So for example, this mine says choose all the ones that are not valid. Right?
Mm-hmm.
So for example, this dot get attribute 2, dot get attribute 6, dot get attribute 4, dot get attribute 1.
Okay, tell me which one is invalid. Which one? Do you know which one it is?
The thing is, mine says this dot, while this doesn't say this dot.
Maybe a different version, right? Option A? E? Over here? Okay. Okay. Let's take a look. So here, attribute 4. Okay, let's be careful here. So we start with B. So if we say attribute 4 at index I, that one is going to give you A. So we traverse to A. And then when you say get attribute 2, that one there is going to give you C. Okay? And then you go to C here. And if you say get attribute 6, that one is going to give you an array. Farrah, that's exactly what you asked me before, right? You can see this one, get attribute 6, is going to give you B array. Now, how can you actually say get attribute 4 on B array? Get attribute 4 is only defined in class B. But here you got an array of B. They're different. So what you really want to compare, okay, I'm glad, is this one here versus nothing over here. They do make a huge difference.
So without index, even an accessible level?
So basically like this. You can think about without the indexing up to this point. Here, the expression has the type an array of B. If you're trying to say, I got an array of B, and I want to get attribute 4 from this array, it doesn't make sense. Because get attribute 4 only makes sense if you have a single value of B. So that's why you have to give some array indexing notation, like over here. That's why. Yeah, I'm glad you asked. It's important. Yeah. Yeah, so that one there is not going to compile. Let me just make a note. Just in case your colleague might be watching the recording. Not compile. Because get attribute 4 only defined in a single B, not in an array of B. Okay. Good. All right, any other questions? Are we good? Should I stop the recording? Okay.